You're welcome to the second episode of collection of problems in algebra and trigonometry. All right, this is the second part of it. In the first part, we talked about sets, we talked about binomials, we talked about inequalities. Okay, and here we are going to talk about trigonometry. So we are going to solve some questions here and just follow till the end. The first question here says, which of the following is correct? Which of the following is correct? Option A, 1 plus tan squared theta equal to cosec squared theta. B, 1 plus tan squared theta equal to cosec cubed theta. C, 1 plus 1 minus cot squared theta equal to cosec squared theta. D, 1 plus cot squared theta equal to cosec squared theta. Option E is none of the above. The correct option here is option D, that says 1 plus cot squared theta is equal to cosec squared theta. Look at question 2. Which of the following is correct? Option A, 1 minus tan squared theta equal to sec squared theta. Option B, 1 plus tan squared theta equal to sec squared theta. C, 1 minus cot squared theta equal to sec squared theta. And option D, 1 plus cot squared theta equal to sec squared theta. Option E is none of the above. The option that is correct here is option B. 1 plus tan squared theta is equal to sec squared theta. Take note of this. Now, these three basic identities you must know. The first one is here, that says 1 plus cot squared theta equal to cosec squared theta. That's one. The second one is the one we established in question 2. 1 plus tan squared theta is sec squared theta. And another one we should also know is that cos squared theta plus sine squared theta is equal to 1. Add this to it. Tan theta is equal to sine theta over cos theta. When we say cosec, or when we say sec, for example, let's start with sec. Sec is secant. Sec theta is 1 over cos theta. Okay, cosec theta, or we write it like this, CSC, cosec theta, is 1 over sine theta. So why sec is 1 over cos, cosec is 1 over sine. Are you there? So let's bear these trig identities in mind so that we can easily answer questions when we see them. Question 3 says tan A plus B is equal to. The answer to this question, which would have been the correct option if I had written the option, is this. Take note. The tangent of a sum tan A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. If I am dealing with the tangent of a difference, tan A minus B, it is similar to this, just that the sign alternates. It will not be tan A minus tan B, okay, divided by 1 plus, are you seeing it? Tan A tan B. That's it. We also have the sign of a sum, the sign of a difference, the cosine of a sum, and the cosine of a difference as well. Look at question 4. We have to evaluate sine 2a minus cos 2a. Sine 2a minus cos 2a. All right, let's go ahead. These are the options. So let's solve and see which of these options is correct. Sine 2a actually is simply sine a Sorry, this is simply sine A plus A. Now, for the sign of a sum, sine A plus B, for example, is sine A cos B plus sine B cos A, or I can say sine A cos B plus cos A sine B is the same thing. You know, multiplication is commutative. So if I am now dealing with A plus A plus instead of A plus B, A is still A, B will now be A. So I will be writing sine A cos A plus sine A cos A. Are you seeing it? So it will now be B will now be A, B will now be A. So sine A cos A plus sine A cos A. And sine A cos A plus sine A cos A will give me 2 sine A cos A. That's the sign of A plus A. Are you getting me? Double angle. 2 sine A cos A is just for sine 2A. Let's determine that of cos 2A. Okay. Cos 2A is actually cos A plus A. That's the cosine of A plus A. Are you there? From trigonometry, cos A plus B is actually equal to cos A cos B minus sine A sine B. That's the point. So if I'm now using AA instead of AB, the B will now be A. So it means that cos A plus A is equal to cos A cos A minus sine A sine A. Are you seeing it? Cos A is actually cos squared A. Then sine A is what? Sine squared A. Now, I can write this in another way. You know that sine squared A is actually 1 minus cos squared A. So this is the same thing as saying cos squared A into, okay, let me go down. Cos squared A minus 1 minus cos squared A. That's it. Minus will give me a plus. So if I'm saying cos squared A plus cos squared A, I'll get 2 cos squared A minus 1. Or if I replace this cos squared A with 1 minus sine squared A, I'm coming from here. I told you cos squared theta plus sine squared theta is equal to 1. So I can make any of the sine squared theta or cos squared theta the subject of the formula. If I make sine squared theta the subject, I'll be having sine squared theta is equal to 1 minus this. And if I make cos squared theta the subject, it will be cos squared theta equal to 1 minus this. So when I made sine squared A the subject, I had 1 minus cos squared A. So if I'm making this the subject now, it will now be 1 minus sine squared A in bracket, then minus sine squared A minus sine squared A. So this is minus sine squared A minus sine squared A. That's minus 2 sine squared A. Sorry, minus 2 sine squared A. Then the 1 is still there. So these two, they are the same for cos 2A. So I can write cos 2A as this or this or this also. The question says sine 2A minus cos 2A. Sine 2A is already 2 sine A cos A. So I'm going to say 2 sine A cos A minus, if I minus this one from it, because we have minus cos 2A in the question. So if I'm using this one as the cos 2A to be minus into 2 cos squared A minus 1. And that will give me 2 sine A cos A minus 2 cos squared A minus 1. Okay, plus 1. This one can be the answer. Or if I'm using, instead of this cos 2A now, I want to use this 1 minus 2 sine squared A. I'll be writing 2 sine A cos A minus 1 minus 2 sine squared A. So I will get 2 sine A cos A. Then this one will multiply this to give me my plus 2 sine squared A. Plus 2 sine squared A. Then minus 1. So let us see which of the options is correct. Okay, 2 sine A cos A minus 2 cos squared A plus 1. Let's locate that here. 2 sine A cos A minus 2 cos squared A plus 1. 2 sine A cos A minus 2 cos squared A minus 1. Wrong. 2 sine A cos A minus 2 sine squared A. Wrong. Okay, so let's see the second one. The second one says 2 sine A cos A plus 2 sine squared A minus 1. 2 sine A cos A plus 2 sine squared A minus 1. 2 sine A cos A plus 2 sine squared A. This is minus, wrong. Okay, 2 sine A cos A plus, this is plus 2 sine squared A minus 1. This is the correct option. Option C. Alright. Question 5 says, express sine 3 theta only in terms of powers of sine theta. Okay, let's do this. Now, sine 3 theta is equal to sine theta plus 2 theta. Do you agree? Because theta plus 2 theta will give me 3 theta. Now, using that trig identity I showed you when I was dealing with sine A plus B, I said that sine A plus B, this is sine A cos B plus sine B cos A. So if I'm dealing with sine theta plus 2 theta, let's take this one as the A. Right, this will be the A. Theta will replace A, then 2 theta will now replace B. So this will simply be this. Sine theta cos 2 theta plus sine 2 theta cos theta. That's it. Okay, so this is sine theta. Now remember, we have evaluated cos 2a before. All right, yes, we did that before, not quite long. We evaluated cos 2a. Good. They are asking us to express sine 3 theta in terms of powers of sine only. All right, that means in the solution there will be no cosine. That's the point. So without even solving, I am going to tell you that option C and option D are wrong because the solution contains cosine, whereas the question asks for powers of sine only. So A or B is the answer, while C and D, they are wrong because they contain cosine. So because the sine 3 theta will now contain sine terms only, I am going to make use of this expression that contains only sine. This one. You know that cos 2 theta is either 2 cos squared theta minus 1 or 1 minus 2 sine squared theta. The one that contains sine is this one. So in place of cos 2 theta here, I'm going to write 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. Plus, we have dealt with sine 2 theta before as well. Yes, we have done that before. When we said sine 2 theta, that's sine 2a in this case, is 2 sine A cos A. So if we are using theta, it will now be 2 sine theta cos theta. Okay, let's see. Sine 2 theta will now be 2 sine theta cos theta. This theta is still outside, so multiply this. All right, sine theta times 1 is sine theta. This times this, that will now be minus 2 sine, the power will increase. Yes. Then if I multiply everything here by cos theta times cos theta is cos squared theta. That will be 2 sine theta cos squared theta. But the question simply said, in terms of powers of sine theta, and now there is cos squared theta in this. We have to do away with it. Remember the identity that says cos squared theta plus sine squared theta is equal to 1. It means that cos squared theta is equal to 1 minus sine squared theta. So I'm going to write that in place of this cos squared theta here. This is simply sine theta minus 2 sine cube theta. Okay, then this is plus 2 sine theta into, in place of cos squared theta, I'll write 1 minus sine squared theta. So we have sine theta minus 2 sine cube theta. Let's expand the bracket. 1 times this, that will be 2 sine theta. Then this times this will be minus 2 sine cube theta. So, okay, let's see. Minus 2 sine cube theta minus 2 sine cube theta is minus 4 sine cube theta. Sine theta plus 2 sine theta is 3 sine theta. You can see now that this expression is now in terms of sine theta only, no cos. This is it. So which of these options will fit this solution? 3 sine theta minus 4 sine cube theta minus 4 sine cube theta. Option A is correct. That's it. We are to express cos 3 theta only in terms of powers of cos theta. That's the point. Only in terms of powers of cos theta. You know, the first question we solved, we express sine 3 theta only in terms of powers of sine theta. So here now, let's see how to do this in terms of powers of cos theta. Cos 3 theta is equal to cos theta plus 2 theta. This is where we start from. Okay, now if we follow this double angle identity, remember I told you that cos A plus B is cos A cos B minus sine A sine B. Okay, so if I'm dealing with cos theta plus 2 theta, A will be theta and B will be what? 2 theta. So I'm going to say cos theta cos 2 theta minus sine theta sine 2 theta. I'm following that principle now for double angles. I'm coming from here now. Okay, so this is it now. Let's go ahead. What is cos 2 theta? Cos 2 theta has two values in the lowest term. Let me say it that way. Is either I choose this, okay, or I choose this, either this or this. But I need the one that will suit the question. They said in terms of powers of cos theta. So it is this one here that has cos theta. This one has a sine. So I'm going to make use of this. Right there, I'm going to make use of this. So anywhere I see cos 2 theta, I'm going to write 2 cos squared theta minus 1. This will be cos theta into 2 cos squared theta minus 1, then minus sine theta in bracket. What is sine 2 theta? Sine 2 theta is, from what we did before, it will be 2 sine theta cos theta. That will be 2 sine theta cos theta. Cos theta times this, that will be 2 cos cube theta. Cos theta times minus 1 minus cos theta. Minus sine theta times 2 sine theta cos theta. If I multiply them, it will now be minus 2 sine squared theta cos theta. Because sine theta times sine theta is sine squared theta. Now, we are trying to simplify this cos 3 theta or expand it to contain cosine terms only. But there is a sine term here, a term that has a sine. So we have to do away with it. Remember that cos square theta plus sine square theta is equal to 1. So if I make sine square theta the subject of the formula, then sine square theta will now be equal to 1 minus cos square theta. So in place of this sine square theta now, I'm going to write 1 minus sine square theta. So we have 2 cos cube theta minus cos theta minus 2 in bracket 1 minus cos square theta into this cos theta outside. So that everything will now be in terms of cosine only. As you can see now, that's what it is. Let's expand. We have 2 cos cube theta minus cos theta. If we multiply these brackets, this is actually minus 2 cos theta outside. So minus 2 cos theta is multiplying 1 minus cos square theta inside the bracket. So I'm going to say minus 2 cos theta times 1 minus 2 cos theta. Again, minus 2 cos theta times minus cos square theta. That will be plus, because minus times minus is a plus. Then cos square theta times cos theta will now be cos cube theta. Are you there? Then the 2 will also multiply this. So if I say 2 cos cube theta plus 2 cos cube theta, that will be 4 cos cube theta. And minus cos theta minus 2 cos theta is minus 3 cos theta. So in terms of cosine terms only, cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Actually, in the question, I didn't write the option here because the option for this question is the same as the option for this question 5. So where is 4 cos cube theta minus 3 cos theta found in this option? It is option C. So if I use this option here for question 6, option C will be the correct option. Are you getting it? So this is it for this question 6. This is question 7. All right. If sine A is equal to 2t over 1 plus t squared and cos A is 1 minus t squared divided by 1 plus t squared, we have to find tan A. I told you just now that tan A is equal to sine A all over cos A. So tan is sine over cos. So what is sine A? Sine A is actually 2t divided by 1 plus what? T squared. And divided by what's cos A? This 1 minus t squared divided by 1 plus t squared. So if I simplify that fraction, tan A would be equal to 2t divided by 1 plus t squared. That division will turn to a multiplication, and the reciprocal of this fraction will be taken. 1 plus t squared divided by 1 minus t squared. 1 plus t squared cancel 1 plus t squared. What's left? 2t divided by 1 minus t squared. It's as simple as this. And this is actually option D. 2t divided by 1 minus t squared. So option D is the correct option for this particular question. Now let's see question 8. Okay, we have to evaluate sine A plus B plus sine A minus B. The sine of a sum plus the sine of a difference. It's also very easy. Now remember, sine A plus B is sine A cos B plus sine B cos A. Yes. and sine A minus B, they are almost the same, just that I will write sine A cos B minus sine B cos A. So if I add these two together, I will get this plus this, right? So to be sine A cos B plus sine B cos A plus everything here. That's sine A cos B plus, okay, plus times minus is still minus. Minus sine B cos A. I hope you understand this. Sine A cos B, sine A cos B. Add them up. What would that give you? 2 sine A cos B. But sine B cos A minus sine B cos A, they will cancel out. So this is what's left. 2 sine A cos B. And 2 sine A cos B is found in option B. 2 sine A cos B. This is the answer to this question. Question 9. If sine theta is equal to 3 over 5, we have to find sine 2 theta. Alright, what is sine 2 theta? Given that sine theta is equal to 3 over 5. We saw that sine 2 theta is equal to 2 sine theta cos theta. That means to determine sine 2 theta, I need sine theta and I also need cos theta. But we are only given sine theta. So how do we get cos theta? To determine cos theta, I'm going to use this trig identity that says sine squared theta plus cos squared theta is equal to 1. So sine theta, okay, let me make cos theta the subject of the formula now. Cos theta will be the square root of 1 minus sine squared theta. So cos theta is the square root of 1 minus sine squared theta. So sine theta is 3 over 5. That means cos theta is the square root of 1 minus, if sine theta is 3 over 5, it means that the square of that sine will be 9 over 25. If you square 3 over 5, you get 9 over 25. So this is it. The square root. 25 times 1 is 25 minus 9 over 25. 25 minus 9 is 16. So we have the square root of 16 all over 25. And that will give me 4 over 5. So cos theta is 4 over 5. I'm going to write cos theta equal to 4 over 5 here. Good. So we can now proceed. So sine 2 theta will now be equal to 2 times sine theta is 3 over 5 times cos theta is 4 over 5. What will this be? 2 times 3 is 6, 6 times 4 is 24. 5 times 5 is 25. For question 10, it says if sine theta is equal to 3 over 5, we have to find cos 3 theta. Remember we said earlier that cos 3 theta is 4 cos cube theta minus 3 cos theta. This is what cos 3 theta is in terms of cosine terms. The question only gave sine theta. We are not giving cos theta, so we must get it. But because we have determined that before, we solved in question 9, we got cos theta as 4 over 5. So we can just use it here also and solve the question. So cos theta is still 4 over 5 because it is still sin theta equal to 3 over 5. So cos theta here this will be 4 into cos cube theta will now be the cube of 4 over 5. So that's 4 over 5 cube rather minus 3 into cos theta, and that's still 4 over 5. Okay. 4 cubed is 64. 64 times 4 is 256. 5 cubed is 5 times 5 times 5. And 5 times 5 times 5 is 125. Minus 4, 3 times 4 over 5. 3 times 4 is 12. So this is 12 all over 5. Alright, let's take the LCM of both. The LCM of 125 and 5 is 125. 125 divided by 125 is 1. Times 256 is still 256. Minus 125 divided by 5 is 25. 25 times 12 is 300. 256 minus 300 is minus 44. All over 125. Alright, so in our question 9 rather, the correct answer is option A, and here in question 10, the correct option is option D, minus 44 over 125. Let's see question 11. Question number 11. What is the value of cos 80 degrees cos 70 degrees plus sine 80 degrees sine 70 degrees? Alright. To solve this question, we don't need to punch a calculator to do this because the options are not in decimal values or they are not in fractions, but they are expressed in terms of cosines of angle and sines of angle also. To solve the question very easily, we use the identity. Remember, there is something like this. Cos A cos B plus sine A sine B. Yes, there's something like this. This is the formula that we have here. So what will produce this? Actually, the cosine of a difference is what will give us that. Cos A minus B is cos A cos B plus sine A sine B. So if you compare this now, 80, that's what's here, A, 70 is here, 80 is here, 70 is here. So you can see that A is 80 and B is 70 degrees. So if I place 80 here, 80 minus 70, what will I get? I'll get 10. So this will be cos 80 degrees minus 70 degrees, and that will give me cos 10 degrees. And that's option A. So when you are solving problems like this, sometimes we don't need to evaluate them using the calculator. It's just for us to resolve, just for us to apply one or two trig identities, and our answer will be out. All right, see this next question. Question 12. What is the value of the cosine of the inverse tangent of root 3 cos tan inverse of root 3 for angles that lie in the interval 0 less than or equal to pi, sorry, this is not pi, this is theta, 0 less than or equal to theta, and theta is less than or equal to pi over 2. Okay, pi over 2 is 90 degrees, and this is 0. So between 0 and 90 degrees, we have angles that lie in the first quadrant. That's it. So actually, they are telling us that the value of this angle here, the tan inverse of root 3, is an angle in the first quadrant, angle between 0 and 90 degrees. So what is the tan inverse of root 3? The tan inverse of root 3 is 60 degrees. That is 60 degrees. So if we are now saying cos tan inverse of root 3, it means that this is equal to the cos of the cosine of 60 degrees. And the cosine of 60 degrees is 1 over 2. Cos 60 is 1 over 2, or 0.5. And this you can see as option B. That's it. Question 13. For what value of theta is y equal to tan theta undefined if theta is less than or equal to, if 0 is less than or equal to theta and theta is less than or equal to pi. Okay, this time it is not pi over 2, it's pi, between 0 and pi. In the first quadrant, we have 0 to 0 less than theta, and theta is less than or equal to pi over 2. Then in the second quadrant, it is from pi over 2 less than or equal to theta, and theta is less than or equal to pi. Get the point now? So the first quadrant is from 0 to pi over 2. The second quadrant is angle between pi over 2 to pi. That's from 90 to 180 degrees. In the third quadrant, from 180 to 270 degrees, and for the fourth quadrant, 270 degrees to 360 degrees. So here now is a combination of two quadrants, the first quadrant and the second quadrant, from 0 to 180 straight. So what values of a theta is tan theta undefined? Tan 180, pi is 180, tan 180 is 0, so it is defined. But tan 90 or tan 90 degrees is undefined. Yes, this is the answer to the question. Pi over 3 is 180 degrees over 3, and that's 60 degrees. Tan 60 degrees is defined, it has a value, and that's root 3. Also, 2 pi over 3 is 2 times 180, which is 360, divided by 3, and that's 120 degrees. So tan 120 degrees also has a value, and that value is minus root 3. For theta equal to pi over 2, the tangent is undefined. That is the point. Now, question 14. Assuming an angle lie in the first quadrant, evaluate the sine of the inverse tangent of 5 over 12. Alright, it's very easy, just for us to do some little manipulations. I want to say, let the tan inverse of 5 over 12 be equal to theta. So if I take the tan of both sides, it actually means that 5 over 12 is equal to tan theta. Are you getting it? So it means that 5 over 12 is equal to tan theta. If we from here now take the tangent inverse of both sides, we'll see that theta is equal to tan inverse of 5 over 12. So on a right angle triangle, I can represent this. Let me put theta here. Okay, just follow. Tan is opposite over adjacent by SOHCAHTOA. That's TOA, opposite to adjacent. So if the angle is here, theta is here, it's facing this side. That means here becomes the opposite. Here will be 5. And here is the adjacent. That will be 12. By the rule of Pythagoras, this is a right angle triangle. By the rule of Pythagoras, we are going to obtain that this hypotenuse will be 13. Pythagoras rule states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. 5 squared is 25. 12 squared is 144. Add them together, you get 169. And that's 13 squared. Yes, so 5, 12, 13, they form what we call a Pythagorean triple. Now, we can now determine sine. Sine is opposite to hypotenuse. Cosine is adjacent to hypotenuse. This is the opposite, and this is the hypotenuse. So for sine theta, everything here now is theta. That's what we said earlier. Tan inverse of 5 over 12, let it be theta. So if we put in theta here, it means that we are evaluating sine theta. Alright? So what will be sine theta now from here? Opposite hypotenuse. So sine theta is actually 5 over 13. This is it. This is the solution to the problem. Sine theta is 5 over 13. Question 15 says, if the tangent of an angle is negative and its secant is positive, in which quadrant must the angle lie? If the tangent of an angle is negative and the secant is positive, in which quadrant must the angle reside? In which quadrant must the angle be? It's a very simple question if I know angles and their quadrant. Okay? We have four quadrants. This is the first, the second, the third, and the fourth quadrant. Alright. In the first quadrant, all the angles are positive. All they are positive. Sine, cosine, tangent, they are positive. In the fourth quadrant, only cosine is positive. Here, everything is positive. It means that in this fourth quadrant, tan and sine are negative. In the third quadrant, only tangent is positive. Take note of this, please. And in the in the second quadrant now, only sine is positive. So there is actually a mnemonic for it, ACTS. If you are going in the clockwise direction, that's ACTS. You can easily remember acts. Alright, let's go back to the question. It says, the tangent of an angle is negative. First of all, in which quadrant is tangent negative? The tangent is negative in the second and the fourth quadrant, and it is positive in the first and the third quadrant. So tangent is negative here and also negative here. Okay. The secant of the angle is positive. What is secant? Secant, that's sec, is 1 over cos. They are saying now that the secant is positive. Take note, if cos is positive, sec will also be positive. And if cos is negative, sec will also be what? Negative. Now that they are telling us that the secant is positive, it means that the cosine is also positive. So the implication now is that this particular angle, the tangent is negative and the cosine is positive. So which quadrant does this angle reside? This is where tan is negative, 2 and 4, right? But this is where sec is positive, the fourth quadrant. Cosine is positive here. Hence, the sec will also be what? Positive. It means that the angle resides in the fourth quadrant. The answer is what? Fourth quadrant. Fourth quadrant. That's where the angle is. This is the answer to the question. Okay? Now, this is question 16. If sec theta is equal to 5 over 4, find 1 plus tan square theta. This is a very simple question. We established earlier that sec square theta is equal to 1 plus tan square theta. So I don't need to even solve for this. What I just need to do is to square 5 over 4. Sec squared theta is 25 over 16. If you square 5 over 4, you get 25 over 16. And this same sec squared theta is equal to 1 plus tan squared theta. It therefore means that if sec theta is equal to 5 over 4, then 1 plus tan squared theta is the square of 5 over 4. And that's 25 over 16. 25 over 16 is the answer to that question. So if sec theta is 5 over 4, 1 plus tan squared theta is 25 over 16. Alright? Question 17 is a similar question. If cosec theta is 5 over 3, we have to find 1 plus cot squared theta. Remember we established earlier also that cosec squared theta is 1 plus cot squared theta. But we are only giving cosec theta and not the square of cosec theta. So to get 1 plus cot squared theta, what we'll do is to square 5 over 3. And that will be what? 25 over 9. It's as simple as this. So given that cosec theta is 5 over 3, 1 plus cot squared theta is 25 over 9, obtained by squaring 5 over 3. Now look at the next question, question 18. We are done with trigonometry for now. Let's now talk about complex numbers. From question 18 down, we shall be solving questions under complex numbers. We are to evaluate the fourth power of I. The fourth power of I. In complex number, one of the basic established facts is that I squared is equal to -1. You must note this. And by implication, it means that I is equal to the square root of -1. So what I have to do is to reduce I to the power of 4 to contain I squared. I to the power of 4 is I squared all squared, true or false? So in place of I squared, I will now write -1. And -1 squared is equal to 1. The answer is 1. Similarly, if you have to evaluate I to the power of 37 now in question 19, I to the power of 37 can be written as I to the power of 36 times I to the power of 1 by law of indices, because 36 plus 1 is 37. Alright. I to the power of 36 is the same thing as saying I squared times 18. 18 times 2 is 36. That's 18 plus 18, right? So if I say 2 times 18, that's 36 by law of indices, then times this I to the power of 1. I squared is -1. So if I'm saying -1 raised to the power of 18 times I, -1 to the power of 18 is +1. When you raise a negative number to a power that is even, the negative sign will disappear. That's what happens here. Times I. So 1 times I will give me I. It means that I to the power of 37 is I. Question 20. The question says, evaluate 1 minus I all squared divided by 1 plus I. Okay, first of all, let us expand that numerator. If I want to expand it, it will be, see how I'm going to do it. 1 squared, 1 squared, 1 squared is 1. Then I will now say 2 times 1 times minus I. 2 times 1 times minus I, that's -2I. I will now say minus I all squared, minus I all squared. What is minus I all squared? Minus I all squared. Minus I all squared means minus I times minus I. Okay, minus times minus is a plus. I times I is I squared. And I squared itself is -1. 1 minus 1 will cancel out to 0. We are actually left with -2I over 1 plus I. We multiply top and bottom by the conjugate of the bottom. That will be 1 minus I. The conjugate is obtained by changing the sign of this imaginary part. Okay. -2 times 1 is -2I times 1 is -2I. -2I times minus I, that's plus 2I squared. 1 times 1 is 1. Alright. 1 times minus I is minus I. I times 1 is plus I. Plus I times minus I is minus I squared. What would this be? See, 2I squared. This is I squared. I squared is -1. I squared is -1. So 2 times -1 is -2. So we are having -2I minus 2 all over I squared is still -1. I squared is -1. Minus I plus I is 0. Right? So we are having 1 minus -1. You must be very careful with this. I squared is -1. So times this minus here become a plus, plus 1. 1 plus 1 is 2. So if I factor out 2, 2 will cancel 2 here, cancel 2 here. We are left with 1, 1. So this will now be equal to -1I, which is -I, -1. Or you can say -1 minus I. They are the same. So that's it for this particular problem. Now, For question 21, let's evaluate this. We have to evaluate 1 minus I all over I. So we have 1 minus I all over I multiplied by the conjugate of the denominator. It is just I here alone. So if I change the sign of this imaginary number from plus to minus to become minus I all over minus I. 1 times minus I is minus I. Minus I times minus I is plus I squared. Then I times minus I is minus I squared. You see it? Okay, let's go ahead. This is actually minus I plus I squared is minus 1. Right? So I should be writing minus 1 here. All over I squared is minus 1. So we have minus 1. So this is simply minus I minus 1 all over 1. This is minus I minus 1. That's it for this question 21. Alright, what is question 22 now? Question 22 says, if Z1 is equal to 1 plus 3i and Z2 is 7 plus 2i, find Z1 times Z2. We have to multiply these two complex numbers. I am not using any long process to solve in this particular video. You can see that I've been cutting some steps off. So I assume that this is an exam condition where you have to be very, very fast. That's why I'm trying to show you some quick approach to solve questions. To multiply those complex number, these two, they are multiplying each other. I will simply say 1 times 7, 7. 1 times 2i, that's 2i. 3i times 7, that's 21i. 3i times 2i, that's 6i squared. Alright, let's go ahead. This is simply, okay, see. I squared is minus 1, right? I squared is minus 1. So this is now minus 6, no longer plus 6. So minus 6, 7 minus 6. This is 7 minus 6. And 7 minus 6 is 1. 2i plus 21i is 23i. It's as simple as this. Okay? For question 23, we have to evaluate 2 plus 3i all over 4 minus 5i. Like what we did before, I think in question 20 and 21, we multiply this by the conjugate of the bottom. At the bottom, we have 4 minus 5i. So the conjugate is obtained by changing the sign of that imaginary part from minus to plus. So we'll be having times 4 plus 5i. This is now plus now. 2 times 4 is 8. 2 times 5i is 10i. Okay, I think I should just come down. This is 8 plus 10i. Then 3i times 4, that's 12i. 3i times 5i is 15i squared. 4 times 4, 16. 4 times 5, 20, that's 20i. Minus 5 times 4 minus 20i. This times this minus 25i squared. Let's go. 8i squared is minus 1. So this becomes minus 15. Okay, minus 15. 8 minus 15 is minus 7. 10i plus 12i is 20. This will be 22i. Divided by 16. Okay, I squared is minus 1. Times minus 25, that becomes plus 25. So 16 plus 25 is 41. Because 20i minus 20i is 0. So we are left with 41. So we can write this as minus 7 over 41 plus 22i all over 41. We are still correct. Question 24 says, Express 2 minus I all to the power of 4 in the form a plus ib. What that means is that we should simplify the expression. That's what it means. Okay, so let's see. This is actually the same thing as saying 2 minus I. Okay, 2 minus I. What is this? This is 2 minus I squared. Do you agree? Yes. Of course, you will agree with me that 2 minus I to the power of 4 is the same thing as saying 2 minus I all squared, all squared. So if I expand the one inside, it will be 2 minus I, 2 minus I, then everything is still carrying a square. That's what I'm saying here. So everything here is taking a square. Expand what is inside. 2 times 2 is 4. 2 times minus I is minus 2I. I times 2 is minus 2I. Minus I times minus I is plus I squared. Alright, I squared is minus 1. Okay, I'm going to raise everything here to the power of 2. We are not done. Alright, don't forget. I squared is minus 1. Okay, so 4 minus 1 is 3. So we're having 3. Minus 2i is minus 4i. So I'm going to square this. Now see, I'm going to square it. See the shortcut I used before. 3 squared. 3 squared is 9. 2 times 3 times 4. 2 times 3 times 4i. That will be, this is 6 times 4, 24. That's minus 24i. Then I will now square minus 4i minus 4i squared minus 4i all squared. This is same thing as saying 4 squared I squared. Okay, because 4 squared is 16, I squared is minus 1. So this is minus 16. You get the point now. Everything there is minus 16. You know, if you raise a negative number to a positive to an even power, the minus will disappear. So this is minus 16. So we are now saying minus 16. 9 minus 16 is minus 7. Then we have minus 24i. Question 25. If z1 is equal to 5 plus 3i and z2 is 4 minus 5i, we have to find z1 bar times z2 bar. When you see a bar on top of a complex number, that means conjugate. So we are actually taking the product of the conjugate of z1 and z2. That's what it means. Okay, so the conjugate of z1 is obtained by changing the sign of the imaginary number. z1 is 5 plus 3i. The conjugate will be 5 minus 3i. z2 is 4 minus 5i. The conjugate will be 4 plus 5i. So the product of this is actually the product of the conjugate of z1 and z2. 5 times 4 is 20. 5 times 5 is 25. Minus 3 times 4, that's minus 3, minus 12i. Minus 3i times 5i, that's minus 15i squared. Okay, I squared is minus 1. So minus 1 times minus 15 is plus 15. 20 plus 15 is 35. 25 minus 12. 25i minus 12i is 13i. This is the product, and that's the answer to the question. We are asked to express this number in polar form, this complex number in polar form. 1 plus I root 3 in polar form. Alright, let's do that. In polar form, we have z equal to arrow cos theta plus I sin theta. Arrow is the modulus and theta is the argument or the amplitude. So to determine this now, we need the modulus and we need the argument. Arrow is the square root of 1. that's 1 squared. B is root 3, that's the coefficient of I, that's root 3 squared. Root 3 squared is 3. The square will take away the square root. So we have 3. 1 squared is 1. 1 plus 3 is 4. And the square root of 4 is 2. The modulus of this complex number is 2. What is next? We now plot this complex number, or we show it on an Gantt diagram. This is the imaginary axis and this is the x-axis. Positive imaginary, negative imaginary. Positive x, negative x. So which of these quadrants does this complex number reside? X is positive 1, that should be here. And this one is root 3, positive I here. So the complex number is actually in the first quadrant. Okay. So it's in the first quadrant. So we can make use of the angle that we'll get. It's simple. Theta is the tangent inverse of root 3 all over 1. That's b over a. And the tan inverse of root 3 is 60 degrees. So this is equal to what? 60 degrees. Or pi over 3 in radians. I write the polar form in two ways, one in degrees and one in radians. Therefore, in polar form, z is equal to arrow and arrow is 2, cos theta is 60 degrees plus I sin theta 60 degrees. If I don't write it this way, I'll write it in, I'll change the degrees to radians by simply multiplying that 60 by pi over 180. I say 60 times pi over 180 degrees. 6 is 1, 6 is 3. That's pi over 3. So this is 2 into cos pi over 3 plus I sin pi over 3. Anyone is correct. And it gives the polar form of this complex number. Question 27 says, express -1 minus I root 3 in polar form. Okay, let's do this. In polar form, we are going to say, like we did earlier, we need the modulus. The modulus is the square root of -1 squared plus root 3 all squared. And that will still give me 2. -1 squared is positive 1. Root 3 squared is still 3. 1 plus 3 is 4, and the square root of 4 is 2. But let's see if the argument will still be 60 degrees. Theta is the tan inverse of root 3 over 1. I did not pick the minus. Okay, that's how to do it. The tan inverse of root 3 is actually 60 degrees, like we saw it before. But this is not the angle I'm going to use. See the reason why I say so. If I plot this complex number on the Gantt diagram, the x is negative, the I is also negative. So I'm using this quadrant now. This is negative x, right? Negative x and negative I. So this quadrant, the third quadrant, the angle is here. Okay, the angle is there. 60 degrees is here. The angle I'm going to use is measured from the positive x direction. From here to here. That's what I'm using. From here to here is 180 degrees. So if I add 180 to 60 degrees, I'll get this full distance. 180 plus 60 degrees is 240 degrees. So the angle I'm going to use is 240 degrees. Let me call that one theta. Let me say it's the reference angle. That's 240 degrees. That's what I'm using. The reason I did not change that angle in the first question, the question 26, was because we have already measured 60 degrees from here. So we are not going to exceed this line. That's why it is 60 degrees for that one. But here it is in the third quadrant, so we have to measure the angle from the positive x direction. The polar form will be z equal to r is 2 cos theta is 240 degrees plus I sine 240 degrees. Or if the angle is in radians, let's convert 240 to radians. 240 degrees times pi over 180 degrees. 0 cancels 0. 6 here is 3, 6 here is 4. That will be 4 pi over 3. So we can say this is z equal to 2 into cos 4 pi over 3 plus I sine 4 pi over 3. This is the polar form of that complex number. Question 28, we are to divide this complex number in polar form. It is very easy. To divide complex numbers in polar form, as it is now, we first of all divide their their modulus. That's 5 and 3. That will be 5 over 3. Then we subtract the second modulus from the first. So I'll be writing cos 150 minus 30 is 120. This is it. It's very easy. So first of all, we divide 5 by 3, then you now subtract the second argument, which is at the bottom, from the first one. Okay. In question 29 now, we are to find the cube root of 27 cos 5 pi over 6 plus I sine 5 pi over 6. Alright, the cube root of a complex number is actually 3. There are 3 cube roots of a complex number. There are 4 fourth roots of a complex number. There are 2 square roots of a complex number. I explained this very well in my video on how to determine the roots of a complex number. Okay, you can watch that video to understand better what I'm saying now. For this particular question, the option, although I didn't write it here because it will consume my space, that's why I neglected the option, but I'll show you how they wrote the option. The options are written in this format, okay, not in rectangular form. There is a formula to determine the root of a complex number. Z to the power of 1 over n is equal to r to the power of 1 over n. Then I write cos theta plus 2 pi k all over n plus I sine theta plus 2 pi k all over n. Since it is cube root, we start from k equal to 0 to k equal to 1 and k equal to 2. That's where we stop. So when we plug in different values of k into this equation now, we are going to get 3 different complex numbers. Each of them is a cube root of the original complex number. You get it? Okay. So they have given us, this is the complex number now, and I told you to find the cube root. Cube root is 1 over 3. So n here will be 3 for this. The cube root of this one will now be 27 to the power of 1 over 3 into 27 to the power of 1 over 3 into cos theta here is 5 pi over 6. That will be 5 pi all over 6 plus 2 pi k all over n. N is 3. Okay. You know 2 pi is 360 degrees. Is 360 degrees, yes. 2 pi is in radians. 360 degrees is in degrees. So if you are leaving the answer in radians, we leave it like this. But if the options are in degrees, we convert 2 pi to 360 degrees. In this particular case, the options are in radians. That's why I'm leaving it like this. Plus I sine 5 pi over 6 plus 2 pi k all over 3. You get it? The cube root of 27 is 3. Okay, I want to simplify this very quickly. See, 5 pi all over 6 plus 2 pi k all over 3. The LCM is okay, for this numerator we have 6, so this will be 5 pi plus 12 pi k. 6 divided by 1 is 6, times 2 is 12, 1 over 3. So the 3 here will times the 6 to give us 18. So we'll be having 5 pi plus 12 pi k all over what? 18. That's what I'm going to write here. Cos 5 pi plus 12 pi k all over 18. The same thing here. 5 pi plus 12 pi k all over 18. This is the cube root. That's it. If z is equal to cos theta plus I sin theta, we are to determine z inverse. That's z to the power of minus 1. There are actually two ways, I think, to solve this question, by either writing it as a fraction and then using conjugate, or the second method, which is simpler, is to use the Moivre's theorem. Okay, the Moivre's theorem says that let's use this complex number now. If we have cos theta plus I sin theta all to the power of minus 1, it is simply equal to cos, the minus 1 will times each of the arguments, minus 1 times theta, which is minus theta, plus I sin minus 1 times theta, and that's still minus theta. And what is this equal to? Trigonometry says that cos minus theta is equal to cos theta. The minus will be swallowed up. And the same trigonometry also says that sin minus theta, the minus will come out. We now have minus I sin theta. That's it for the question. It's as simple as this. Now in question 31, we have to express minus 1 plus I in the form rho e to the power of I theta. We call this the Euler form, or the exponential form of a complex number. So converting a complex number in rectangular form to exponential form, we need the modulus of that complex number and the argument. The modulus is the square root of minus 1 squared plus 1 squared. Square this one, then square the coefficient of I. Okay. Minus 1 squared is 1. 1 squared is 1. And this will give me root 2. So the modulus of the complex number is actually root 2. What is the argument? Theta. Before we determine the argument, let's see which quadrant this complex number resides. Minus 1 plus I. Minus 1, that's the negative x-axis here. Then positive I, that's the positive imaginary, that should be here. So it is in the second quadrant. Negative 1 for negative x, positive I, that's positive 1i for positive imaginary axis. So the angle I'm going to use is the angle measured from here to here. Yes, I'm not going to use this angle here. And this angle here, if we determine that theta now, we are going to say the tan inverse of b over a. And b is 1, the coefficient of I, and 1 here. We don't take the negative, I told you before. We take the positive of them. 1 over 1 is 1. The tan inverse of 1 is 45. That's 45 degrees. Take note of this. In exponential form, we always leave the angle in radians, not in degrees. So I'll convert that 45 degrees into radians by saying 45. Let me do it here. 45 times pi over 180 degrees. 45 here is 1. Here is 4, right? Yes. So 45 degrees is actually pi over 4 in radians. So we have pi over 4. So here is pi over 4. But I'm not going to use pi over 4, which is 45 degrees. From here to here, from here to here is 180. So if from here to here is already 45, It means that I have to subtract 45 from 180 to get from here to here. You see, the full angle on the straight line is 180. Remove 45 from 180, we'll get this argument, and this is the one we need. 180 is pi. So if I say pi minus pi over 4, 4 times pi, 4 pi minus pi, that's 3 pi over 4. So I'm using 3 pi over 4 instead of pi over 4. So in exponential form or in Euler's form, it is arrow e to the power of I theta. Arrow is root 2. Exponential or e to the power of I, and the argument is 3 pi over 4. 3 pi all over 4. This is it. And I can see this in option. Okay, I wrote option in this one for a reason so that we can understand very well. Option C. Yes. The geometrical representation of complex numbers on the xy Cartesian plane is referred to as, let's say, simply Argand diagram. That's option B. It's an Argand diagram. You know, the normal xy plane, that's the x and y axis, the Cartesian rectangular system. But we're not talking about complex number, but we call it the complex plane or the Argand diagram. Okay. This is it for the part 2 of collection of problems in algebra and trigonometry. All right, I hope to do more of this, solving more questions. Okay, we still have some aspects that we have not talked about, such as quadratics. For the meantime, I hope this video will help you to write your exams and pass very well. Thanks for watching, thanks for following, thanks for being part of this community. Make sure you like this video and share it with your friends and your classmates. Just keep following, keep watching. I'll see you in the next one. I am the complex analyzer, and I'll see you in the next video.